Very good morning. Today's concept is OOPS object-oriented principles. Object-oriented principles. We are having 1, 2, 3, 4, 5, 6, 6 object-oriented principles, which are really required, which are really used in Swift. One is class, another one is object, encapsulation, abstraction, polymorphism, and inheritance. These are the object-oriented principles. What is class? Class is a logical structure to create an object. Just a definition. We have a couple of definitions as well. Object is equal to physical implementation of class. Class is a logical structure, whereas physical object is physical structure. Encapsulation is binding instance variables and methods together. Abstraction is hiding unnecessary behavior and exposing necessary functionality. Inheritance, deriving functionality from an existing class. Polymorphism, overloading and overriding. Let me explain. First thing is okay. We have a couple of data types. Whatever data types we have seen so far is let is equal to int some 20. Let name we have seen string equal to 300. Let course again have string. Let duration float 765.5 days. Assume that let is online course, which is boolean, is true. Couple of data types we have here, and we create custom data type called some weekday, which was string, the string. We had weekend, Saturday, Sunday. Now here, if you let me create a weekend variable as well, a day, week, and equal to weekend. How to access the enum variable? Weekday dot weekend weekend dot Saturday. Why it is not populating? Let's see. Will it any errors here? There are no errors. There's supposed to be no errors. Here, if we clearly observe, this is a variable which is holding one value. This is a variable which is holding one value. All these are variables which are holding only one values. Only one values. Now, I want a variable which holds multiple values. We have tuples. Okay. Here, that is grouping multiple values together is tuple. Again, there is different, each variable, each value is accessed by index or by using labels. Okay. Now, let me create a information about a student. Let a student name string in let roll number is integer equal to 001. Let address is string Chennai. This is for one student. If I want to another student information, again I need to take a student roll number A student address. Again, I will take B student roll number, B student address. Similarly, if I want one more student, I want third student information. I want to store third student information. Again, I need to put C, C, C. Here, what is happening? To declare one, to create one student, what we have to do is we have to create a different variables with different names. Here, A student, B student, C student. Okay, different names you need to create. If you want to create 100 students, you need to write 300 lines of code and 300 different variables. This is one variable, this is another variable, this is another variable, because each one is holding only one value. I want to hold all these values with one variable. I want to hold all these values with one variable. Okay, and this is the information about the student, right? To hold the complete student information, there is no data type. To hold the complete student information, there is no data type. Whatever data types we have seen so far is only storing one value. If we take integer, it is taking one integer only. It is not taking multiple integers. It is not taking multiple integers. Okay, it is not taking one string, one integer, so on so. Now, this is the requirement. I want to store the information about the student. I want to create my own data type like a student. Then I can store information about the student. Shall we create our own data type? By to create our own data type, we have seen enum. Enum is one thing, but it holds only one value. But I want to hold complete information about the student. Complete information about the student. To create our own data type, we also have two other ways. Structure is one thing, class is another thing. By using these two keywords, struct, actually keyword name is struct and class. By using these two keywords, we can create one data type, one data type which can hold multiple values. Which can hold multiple values. We have enum here, right? Let me put structure here. Struct student. Okay, student and its name. Name is address. That's it. Student is a data which can hold multiple values. Sorry, we need to also specify name is string, int age is int, address is again string. This is very simple. This is how we can create structure. This is how we can create structure. This is the syntax of the structure. Struct is a keyword. Student is a structure name or data type. These are fields, structure fields. These are structure fields. Okay, this is called logical implementation. Once one student, whenever you are constructing the building, we have layout plan, right? Layout plan we have, or building plan we have. Building plan we have. Model building plan. Model building plan model we have. In entire layout of 10 acres, they construct only one model building. To construct that also, they create some blueprint, some logical design. Logical design means the architect. They first write it on the paper. They first draw it on the paper. Once the drawing is over, then they will construct the model building. Once the model building is constructed by using that drawing, okay, the same drawing can be applicable to the all the buildings in that particular layout. Okay, here building is actually building, constructing the building is an object, whereas architecture of the building is class. Once one architecture is ready, you can construct any number of buildings, any number of houses. Let's say I am having 10 acres layout. I want to sell that. to sell that. I am having 10 acres layout. I want to construct one house. I want to construct houses in the entire 10 acres layout. To construct a house in the 10 acres layout, what we do? First, we consider architect, and we get some drawing. What is the width of the house? What is the length of the house? And where the dining table comes and where the bedrooms, where the hall, everything is drawn. That is called logical design, or for drawing on the paper, you do not need any space. For constructing the building, you need some space. For constructing the building, you need space. Here, when you create class, this is architecture. This is the architecture of our student class. This is the architecture of student class. Let me put a structure car. Car contains brand. Car contains fuel type. Fuel type I can create one enum, right? Fuel type generally, let me put diesel or variant. Variant we can say. Variant. Which year model? Let number of wheels is integer. Let do have ABS. ABS. This is one car. Car contains brand, color, simply variant. We have. Let me put color. Color. I'm putting string. Color also we can have enum, because limited number of colors. You can also have enum. Here, this is the architecture. This is the architecture of the car. This is by using structure, we can create architecture. For drawing on the paper, we do not need any memory, any space. For constructing, for buying the car, once you buy the car, to keep the car in our home, you need some space to keep the car. Okay, that is, car is an object. Once you purchase the car, that is object. Once you construct the building, that is object. Object can be touch and feel, whereas class cannot be touch and feel. Class is simply logical structure. On the layout, once the architecture draws the plan, you cannot touch and see that. You cannot touch and see the walls. Since it is simply architecture does not require any memory. You just ignore if you do not understand that. This is how we create our own data types. Student data type here, car data type here. Now, once student data type is available, once architecture is available, you can create n number of objects out of it. Once student class is ready, you can create n number of students. Shall we replace this? Let Imran equal to student. Just open. Once you open the parenthesis, it is asking you, provide me name is of type string, age is of type integer, address is of type string. I'll return you student. I'll return you student. Okay, here Imran 001 string Chennai. We don't need all these things. You can replace all these 3 lines with this. Similarly, let me create one more student. Madhu is of type student. Here also you can explicitly specify student equal to student. When you open the parenthesis, this is called Madhu 001, 002 here. Hyderabad. Nandini. Student. Nandini is of type student. Here student of name. Pass the name. Nandini 003. Sorry, yes. something, and that's it. You can replace this. Now we have three variables. So we can simply identify them as a student. This is how we are creating. Now, this student, we have created a student. Student, once the student is ready, you can touch and feel. In the sense, it needs memory. Objects needs memory. This is called actually object now. It is called object. This is called structure. This is called structure. This is called initialization. Object initialization. Initialization means providing the values and constructing the student. Constructing the student. To construct the student, to construct the building, you need to provide some inputs like number of bedrooms you need, number of bathrooms you need, number of balconies you need, number of windows you need for building, constructing a building. For constructing a student, I just expected name, age, and address. So I have passed them. So the student is created. If you do not pass anything here, you cannot create, because the requirement of the student is these things, these fields. These fields are required. If you omit that, it gives you error. Missing argument type, arguments for parameters, name, age, address. Clear how to construct, how to create structures, and how to construct, how to use the structures, and how to access the structure variables. How to access the structure variable. That name, I want to change something in run con. I want to change it. Here, name, I want to change it. This is how you can access the structure variable. I want to change the name. See what happens. Run it. Name is let constant. This is constant, right? So we need to make it var. We need to make it var. Again, there is one more issue here, one more error. Let's run it. Even the object is also, you know, you need to change that to var. Everything is done. Clear? Let me remove all these things. To make it clear, let me remove these as well. I just want to print information about the Madhu. Name. How to access structure will Madhu object name dot field name /n is, which gives you the next line. Madhu dot is /n next line. Madhu dot address. This is how you can access the fields. Here to set the value, we are accessing. Here to read the value, we are accessing. Accessing the structure fields is very simple. Structure object dot field name. Structure name dot field name. Structure variable name dot field name. Name is so and so. Clear how to access the structure variables, structure fields, or structure properties, we can say. These are called properties. In our terminology, we use properties in Swift. In other language, they use to call it structure variables or fields. Okay, how to access the structure fields? Create a structure, use dot notation, and access it. The structures also having. Now you can ask what is the difference between tuple and structure. Tuple is also grouping multiple values together, similar to this. Okay, similar to this. It is structure only, right? Actually, it is actually looks like tuple only. Tuple, just remove this. Just remove this. Once you remove this, it becomes tuple. It will become tuple. Tuple dot name, we cannot actually set the value. Tuple dot name, we can read. Okay, Imran, I have read. Here, coming here, I'm printing Madhu information. Name is Madhu. Age is 34. Hyderabad. Address is Hyderabad. Okay, and then what is the difference between these two? Almost similar, but let me try to put the value here. tuple dot name is this non-con. Is this possible? And tuple dot name. Let me try to print that. Yeah, this is also even we are able to set the value similar to structure. Then what is the difference? These two are almost similar. Basically, there is no data type here. We are grouping multiple values together. Here also we are grouping multiple values together by using structure. Then the difference here is structure can also have methods or functions. These are actually methods. Now these are methods. The difference between method and function. When you declare a function somewhere here, right? Say hi. This is function actually, which is not part of any structure or any class. Here, this is called method. This is called method because it is part of structure. When any function which is part of either class or structure is known as is associated with something, whether it is structure, class, or enum, a function which is associated with any structure, enum, or class, that is known as method. This function is not related to anything. This is a global function. Anyone can access it, but this cannot be accessed. Read. I'm just putting something. I can put name reading. Okay, this is a function. This is a method. Structure can also have, in addition to the variables, in addition to the properties, structure can also have functions. Then you can say no methods. Functions can also have multiple methods. Read, write, print, name, writing. Functions can also have methods, but whereas tuples cannot have. Okay, how to call these functions? However, we are calling the fields same way. We need to call. We know how to call this method. Read, right? But this is not accessible because this is part of structure, right? You need to have to call that method imran.read, imran.write. This is how we call the fields. This is how we call the methods. This is called caller. Caller. We're calling a method. This is caller. This is called calling. Okay. This is the handwriting is calling here. Since we are calling here, whoever is listening to that is calling. This is called a method implementation. When any, this is called function signature, method signature. Okay, let me write that as well. This is known as, in terminology, method signature. When it has curly braces, open and closing parenthesis, means that is called implementation, method implementation. Method implementation or method body. Okay, terminology. When any function, any method which is having curly braces, that is called implementation. Method is implement method. This is called method implementation. If you see something similar to this, only method name, that is called method signature or function signature. Here, whoever is calling this method, he is caller. Here, this is called caller. Whoever is listening to that is called calling. Okay. Let me. This is function. This is method. This is method because these are associated with structure. This is not associated with anything, so it is function. These are associated with structure. Okay. Let me. This is clear, right? Once the structure is ready, you can create n number of objects out of it. I have created 3 different variables. Okay, even let me remove this. I have created 3 different students. Okay, structure is a keyword. Student is a new data type, custom data type, where structure can hold 3 different properties, and the structure can also perform these 2 operations. These are called actions actions or methods or behaviors. Actually, behaviors or actions we call. These are called properties. In Swift terminology, okay, these are called properties. All these are properties. All these are behaviors or actions. Whatever student does, those are behaviors. Student behavior. Okay, student behaviors are as given as part of as like methods. Student can read, student can write, student can sleep. Okay. Any doubts here? You can also do something here. How to access the structure variable? If you are creating structure variable and if you want to access the fields of the structure, this is how structure variable dot field name. If you are accessing within the functions of the within the methods of structure, then you don't need to put anything. Directly you can access name. Directly you can access age. Okay. If you want to modify how do we modify? You have to make this variable. Even here also you need to make variable in case of structures. In case of classes, that is different. We'll see. In case of structures, you need to make this to as var. Okay. If you want to modify within the here we are modifying the field, right? Okay. I want to increase the age. I want to increase the age. I can write one method, right? Thank you. Update age. How to update age? I'm just adding one value. Age equal to age plus 1 year. I'm updating. Okay. I'm trying to modify it. See what happens. Update age is the method. Cannot assign property age is let constant. First thing is age you are trying to modify, but that is constant. You cannot modify. That is clear. That is rectified. Cannot assign property. Self is immutable. Immutable. Self means current thing. This thing. The student. This current student is immutable. Immutable in the sense it is constant. Student is constant. You cannot modify here. That is the meaning. To make that working, mutating is the keyword. Mutating means mutable means modifiable. Immutable means constant. Simple. Mutating to modify any structure variables within its structure methods. You need to make that method. You need to mark that method as mutating. This is mutating method. What is the purpose of mutating method? If you want to modify properties of a structure, you need to use the mutating keyword. You need to use mutating keyword. We create n number of classes. Need not to worry. Okay, we'll definitely understand. Any doubts here about structures so that we can go for classes.